Hello everybody, welcome into another lesson and welcome into a brand new unit of rational functions. So today we are going to kick off the rational functions unit with inverse and joint variation. Now, you may recall from earlier in the course and in previous courses, of course, we talked about direct variation, where you have y equals some constant of variation k times x. That is direct variation. That would be more like y varies directly as x when x equals 5 and y equals -2. Let me get an eraser. But I know in past courses we've also mentioned inverse variation, which this means, so here we have y varies inversely as x when x equals 5 and y equals -2. So what we need to do first is find the constant of variation. So when it varies inversely, y varies means y equals. And it varies inversely as x. What that means is you have that constant of variation k divided by x. So if y varies inversely as x, that means y equals the constant of variation divided by x. So what we've just done is we've set up the general form of inverse variation. Now to solve for that constant of variation, you're just going to plug the x and y values in. So y equals -2, so put in -2 for y, that's going to equal k divided by that x value of 5. And then we can easily solve for k by multiplying both sides by 5. You would get that k equals -10. That was easy enough. And then the next goal here is to write a function for y equals that k over x. Well, we found k to be -10, so this would turn into y equals -10 over x. So the result we should get for the new function would be y equals -10 divided by x, once you find that constant of variation. Okay, I got plenty more where this came from. Alright, we're going to have a little bit different here. Do it with a little bit different values. Then we're going to talk about joint variation today also. This time we'll have x equal 4 and y equal 8. Okay, so y varies inversely as x when x equals 4 and y equals 8. Well, go ahead and set up your function of inverse variation. So that'll be y equals that constant of variation k divided by x, since it varies inversely. Now, they do tell us in this case y equals 8, so you'll have 8 equals that k divided by your x value of 4. So then just multiply both sides by 4, you end up getting that k equals 32. So now we found the constant of variation. We need to find the equation of variation. So take your original format, put that k value in. That means that y would equal 32 divided by x. So this particular equation of inverse variation would be y equals 32 divided by x. Alright. Well, yeah. Suppose we better change the values again here. Alright, so let's see. X equals 7 and y equals 1. So this time y varies inversely as x when x equals 7 and y equals 1. So we have the general form of inverse variation, y equals k over x. So y equals 1, so we'll have 1 equals that k divided by that x value of 7, and to solve for k, multiply both sides by 7, you would get that k equals 7. So we just found our constant of variation. Now, to find your new equation of inverse variation, take that k value, put it into the original, you'll get that y equals 7 over x. So this particular equation of inverse variation is going to be y equals 7 over x. So inverse variation's pretty simple. But we'll still do a couple more with inverse, then we'll move into joint variation. Alright, let's see here. X equals 1/2 and y equals 10. Okay, so we have y varies inversely as x when x equals 1/2 and y equals 10. Well, let's go ahead and put this in here. So you've got the y is 10. That's going to equal that k, that constant of variation, divided by your x value of 1/2. Well, what is k divided by 1/2? You have a fraction in the denominator. Whenever you have a fraction in the denominator, you just invert and multiply, right? So this would really turn into 2k equals 10, which would mean your constant of variation, k, would be equal to 5. So we found the constant of variation to be 5. Now to find the actual new equation of inverse variation, this would just be y equals that 5 over x. So y equals 5 over x is your equation of inverse variation. Got two more for inverse, then we're going to do some joint variation. Okay. This time we're going to have it differently. X equals -2/3 and y equals 6. So y varies inversely as x when x equals -2/3 and y equals 6. So that y is 6. Let me write in a different color, huh? Yeah, let's write in a darker color. So y would equal 6. We don't know the constant of variation yet, but we do know that the x is -2/3. Okay, well, again, you have a fraction in the denominator. That's the same as inverting and multiplying. So this would be the same as -3/2 k would equal 6, which means that -3k equals 12, which means that k equals -4. So your constant of inverse variation is -4. Now we can just find the new equation of inverse variation. Just put that k value in, you'll get that y equals -4 over x. So your equation of inverse variation in this case is y equals -4 divided by x. And I got one more for inverse, then we'll move on to some joint variation problems. All right, let's see. X equals 3/4 and y equals 3/8. So y varies inversely as x when x equals 3/4 and y equals 3/8. So we got our setup here, y equals k over x. So the y is 3/8, so that'll turn into 3/8 equals k divided by your x of 3/4. Well, that fraction in the denominator means you just invert and multiply. This would mean that 4/3 k equals 3/8. All right, Multiply both sides by 3, you'll get that 4k equals 9/8. Now divide both sides by 4, you'll get that k equals 9/32. We have a real funny one. So k equals 9/32. So how the heck are we going to write that? Well, let's come over here and find our equation of variation. So this means y would equal 9/32 over x. Well, what is true for that denominator? If we divide by something, isn't that the same as inverting and multiplying? This would be the same as 9/32 times 1 over x. So in short, y is going to equal 9/32x. That would be your equation of inverse variation. Y would equal 9/32x. So it's definitely good to know how to invert and multiply when dealing with complex fractions. And these will come up in this unit. Okay. So there's inverse variation. Let's talk a little bit about joint variation. All right. Now, joint variation can take several forms. So, one form which we're going to start with is y varies jointly as w, x, and z when y equals 10, w equals 1, x equals 2, and z equals 3. Okay. So this one is y varies jointly as w, x, and z when y equals 10, w equals 1, x equals 2, and z equals 3. Okay, so when it just says jointly as 2 or more variables, it really means direct variation with multiple variables. So this will be in the form of direct variation. Y would equal that constant of variation, and it varies jointly as these variables. So this is really referring to multiple direct variation. So that constant of variation of k times w times x times z. So you would get y equals kwxz. Now you just need to find that constant of variation and input all your values by inputting all your values into this setup here. So y is 10. That means 10 is going to equal k times your w of 1 times your x of 2 times your z of 3. So what does this mean? That means then that 1 times 2 is 2 times 3 is 6. So that means that 6k equals 10, which would give you that k equals 5/3. So your constant of variation is 5/3. Now we just need to find the function of the new equation of joint variation, which would have to mean that y equals that constant, which would be 5/3 times w times x times z. So what you would get is y equals 5/3 wxz. If it just reads that y varies jointly as several variables, then it's direct variation just with several variables. That's really all that is. I'll do a couple more of this type there is another type also, joint variation, but we'll get into that in a minute here. So let's see. So Z varies jointly as X and Y when X equals 3, Y equals 8, and Z equals 6. Alright. So Y varies jointly as X and Y when X equals 3, Y equals 8, and Z equals 6. Well, again, you want to set up your equation here. Now, it just says it varies jointly as these variables. So that means this is multiple variable direct variation. So Z varies, that means you're going to have Z equals jointly as X. So the jointly part, you'll still have your K, your constant of variation, times that X and Y. So Z would equal KXY is the setup for this general equation of joint variation. Now, we need to find that constant of joint variation. So Z equals 6. We don't know K. That's what we aim to find out. Now, X is 3. Y is 8. So that means then we got to solve for K. 3 times 8 is 24. So 24K equals 6, which means your constant of variation K would equal 1/4. So there's a critical piece that we need, the constant of variation being 1/4. Now we just need to find the new equation of joint variation. So put that value of K in, you'll get that Z is equal to 1/4 XY. So there's your equation of joint variation. Z equals 1/4 times XY. All right, let's spice this up a little bit here. We'll do one more like this, then we'll do the other type of joint variation. Oh yeah, good one. So we have X equals 3/8, Y equals 16/17, and then Z is going to equal 3/2. Okay. Good one. So Z varies jointly as X and Y when X equals 3/8, Y equals 16/17, and Z equals 3/2. So it just varies jointly. Z just varies jointly as X and Y. That means this is two variable direct variation. So you'll have Z equals that constant of variation K times your XY. So you would get Z equals KXY for your general format. Now the goal is, let's solve for that constant of variation. So input your values. If Z's 3/2, so we'll put 3/2 here where Z goes, will equal that K, which we do not know just yet, times your X value of 3/8, times your Y value of 16/17. All right. I'm actually going to suggest we try to get rid of the 3/8 first. So multiply both sides by 8. You would end up getting 4 times 3, which would be 12. So, yeah, 8 times, let's see, 8 divided by 2 is 4. So 4 times 3 is 12. You would get 12 equals 3K times 16/17. This is going to take a few steps, which then means that we divide both sides by 3. That would mean that 16/17 k would equal 4. Okay, now we got to figure out what the heck is, we got to multiply both sides by 17. What the heck is 4 times 17? That'd be 68. So 16k would equal 68. And then we just solve for k. That'd be 68 divided by 16, which would actually be 17/4. So your constant of variation would end up being 17/4, which means now we can just put that constant of variation into the original format and find our equation of joint variation. That means that z would equal 17/4 xy. So there's your equation of joint variation. Z equals 17/4 xy. Alright, so that's one type of joint variation. Now let's talk about the other type. Another type is where you can have both inverse and direct variation in the same problem. So I will show you how that works. If it just says jointly, that's direct, but if it has inverse and direct, it'll come out and say that. So, for example, x varies inversely with y and directly with z when x equals 8, y equals 5, and z equals 2. Alright, so here's a fun one. You have x varies inversely with y and directly with z when x equals 8, y equals 5, and z equals 2. Okay. So we need to set this up. So x varies, you could think of that as x varies, so x equals inversely with y. What does inversely with y that means? That means that you have your constant of variation k divided by y. Since it varies inversely with y and directly with z, that means you would have all that times z. So really you would have x equals k over y times z. That is the format for this, since you have the mixed variation. It's just a matter of reading x varies, which means x equals. Immediately put your constant of variation, the k. And then when it says inversely with y, that means that constant is divided by y. And directly with z, that means it's all that times z. If that makes sense. Now, let's see here. So input your values to solve for the constant of variation. So x equals 8. That equals the constant of variation k, which we do not know just yet, divided by that y of 5, times the z of 2. Well, in short, you could say that 2k over 5 equals 8, right? Which means that 2k equals 40, which would have to mean your constant of variation k is equal to 20. So we found a critical piece. The constant of variation is 20. Now let's write the new equation with that constant of variation. That means that x would equal 20 z over y. That would be the best way to write this. X would equal 20z over y with your constant of variation, because 20 divided by y times z, of course, is 20z divided by y. So that's how that works. All right. Now we have another one here. We have two more problems. You're also going to see that variation is not always linear. Nope, it's not always linear at all. Let me show you for this next example. So, y varies jointly with z and the square root of x. When x equals 4, y equals 5. No, that's not what I wanted. Y equals 5 and z equals 6. Okay, so y varies jointly with z and the square root of x when x equals 4, y equals 5, and z equals 6. Well, again, it just says jointly, so this means it doesn't say anything about inverse. So if it just says jointly, that means direct variation with multiple variables. So y varies, that means that's going to be y equals, always put your constant of variation, k. It varies jointly with z, so k times z, and the square root of x, so times the square root of x. So your setup should be y equals kz times the square root of x. Now we want to solve for our constant of variation, k. So put in the y value of 5. That's going to equal k, which we don't know yet, times your z value of 6, times your x value, really the square root of x, which is the square root of 4. So let's simplify this here. That means 5 is going to equal k times 6. Now what's the square root of 4? That's 2 times 2. This means that 12k equals 5. So that means simply that your k would equal 5/12. So your constant of variation is going to be 5/12. Now all we have to do is put it into your equation, and you'll have your equation of joint variation. So that means y would equal 5/12 z times the square root of x. So that is your equation of joint variation. Y equals 5/12 z times the square root of x. So this proves you're not always going to have linear results. And I have one more mixed joint variation problem. All right. Good one. So W varies inversely as x and jointly with y and z when W equals 100, X equals 5, Y equals 50, and Z equals 20. So we got some bigger numbers involved this time, but here's the problem. So W varies. Let's start there. W varies. That's going to mean W equals, right? Let me set up the initial problem. So W equals, W varies. So let's stop right there. After the equal sign, put your constant right away, the K. That's the next thing you should do. Now, how does it vary? It varies inversely as X. So that means it's going to be divided by X. So far we have W equals K divided by X, and jointly with Y and Z. Now if it says and jointly with Y and Z, this is basically meaning you have two other variables of direct variation. So you would have Kx times YZ. So what you should get is W equals K over X times YZ. Now, of course, the next thing we want to do is solve for that constant of variation. So put in all the values here and solve for K. So W equals 100, right? So there's 100. That equals K, which we don't know yet, divided by your X of 5, times your Y value of 5, and your Z value of 20. Okay. So, let's multiply everything by 5 first. That would have to mean that you would have 500 equals K times 5 times 20. Well, what's 20 times 5? That's 100K. That means that 100K equals 500, which would just mean that K equals 5. So your constant of variation is 5. We found the critical piece there. Now we can find the equation. So put that K in, you'll get that W would really equal that K of 5 divided by X, then times Y times Z. So you could write this as 5YZ over X. So W will equal 5YZ over X. So that's really it for inverse and joint variation. The next lesson, the next few lessons actually, we're going to graph rational functions. In the next lesson, we're going to start out lesson 1 of graphing rational functions, where the degree of the numerator is less than the degree of the denominator. So I hope everyone has a great night. Take care.